I mean, like if you got the 30 minus 2x and the x with x at 30, but the opposite happens, so that one goes over.
So 76 in section 3.1.
This says other one.
Oh, all right. So we got to the point. This is 76 in section 3.1. Yesterday, I think it was this year, right?
Yeah.
So part A says, what's the cross-sectional area function? Yeah, it's a beautiful rectangle. Appreciate that. All right, so it's just 30x minus 2x squared, right? Just multiply this. Length times width. Gotta love that when that happens. So that's part A. Part B, find the value of x that maximizes this. Now, I'm not going to do any work on that. That is a parabola. It's quadratic. Can you identify what B is? Can you identify what A is? Negative B over 2A, right? That'll finish that problem off. Yeah. So part B and C are the two parts of the vertex. So when you find a vertex, it's a point. So the x piece and the y piece in this problem means something physical. So part B asks for the value of x that maximizes the cross-sectional area, which relates, of course, to the dimensions of it. And part C says, well, what is that maximum area? Then you just got to plug it in. Cool. I'll knock it. So it's just like the other problems, except the first step was you had to create your own function, whereas in the other problems, they were giving you the function, right? I won't be that nice. I'll do one more like this on the test. Yay, Jeff. Yes? All right, so they give you... This one I think is just ugly with the numbers. They give you the formula for the height of a ball. Oh, it's not the height. This is the... Oh, that's why it's different from what I know. Blah, 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 blah. A ball is thrown, it can reduce the path of the ball, x is the distance feet the ball is traveled. Okay, cool. So this is in terms of the distance traveled. So this is x, and the height, of course, will be y. So it's nice and normal, what we're used to. So that's the function that they give us. I would take a second, I don't know why they necessarily... Now, the reason they did this, I guess, is 32 is actually a physical constant. It's due to the gravitational acceleration. Right? It's 32 feet per second per second. So if you drop something from the top of a tower, it starts at 0 feet per second, and every second it picks up another 32 feet per second of velocity. Did you have to know any of that shit to do this problem? No. But I wanted to point out, maybe that's why they didn't actually just give you what the hell that number is. You see, I mean, my first thing I would do in this problem is simplify that number. Right? It's a problem. Work it out. And then you'll know what A is, you'll know what B is, and then you can go from there. Does that make sense?
Can you say it again?
I'll try. So whenever you see the question, find the maximum, find the minimum, I know I'm going to have to find the vertex, and the easiest way to find the vertex is how? Negative B over 2a. So I just keep backtracking. The question said find the min or max. I've got a quadratic. That means find the vertex. I find the vertex by getting negative b over 2a. What do I need to actually do that? What is b? What is a? You see, I mean, just kind of work back to see, this is what I want. This is how I get it. What do I need to do what I need to get what I want? I like the grammar that said. There's a life lesson in there somewhere. English, it be powerful. So I know what B is. B is 1. I just got to figure out what the hell A is. Right? Just simplify this to get what A is. That's what I meant earlier when I said that. But this one again, it almost can't be hard. The only thing you do to make this hard is to make A or B ugly. And they did it. Yay for them. But I just got to simplify this. And I know the process to use. Just not. They can't make it so hard. They can't. I don't even care that they make this ugly. I just do it and throw it in there and do it. Right? All right. Cool. Just.
Are you against us using decimals in a problem like this? Because when we have a calculator, it's pretty easy.
In general, I am. I'm totally against decimals in the middle of a problem, especially when you're rounding. Right? If you get 2/3 and you put down there 0.7 in the middle of a problem, that sucks. You're going to be way far off. I always think about a ship. You're 1 degree off. 8 hours later, I don't know where you are. You're goodbye. No one's going to see you again. So if you round in the middle of a problem, no good. If at the end of the problem, like if I said, how much does that book cost? And somebody told me, about 7/8 of a dollar. So then you can round to make it make physical sense. Right? Yeah. But if that's not, if that number comes out to a nice decimal that you can write the whole damn decimal, it's not 18 places, then okay. But in the middle of a problem, don't round anything, ever. Because that'll throw your answer off. Cool. All right. Anything else from homework? You guys doing all right? Web of Science School?
Yeah.
All right. I get both sides of that. I hear it both ways.
There's a person to talk to sometimes. Yeah, but sometimes you need to hear it twice,
This is right.
Playing.
This is right. And you need to hear it from somebody else sometimes. It's like, that's enough from Jeff, man. He talks too much. Let me go talk to somebody else. I don't know if you can pick up. I actually am a little angry this morning because I was looking through the homework stack, trying to get the homework updated on the computer to try to give you these grade sheets, because I'm also going to tell you what homework I'm missing. And there are people that are doing their own assignments, which I really appreciate that a lot. They're doing only the odd problems, or they're doing every 8th odd or something insane, right? And I'm like, why is the stack so short? Oh, that's why. So, just do the assignment. Right? Write the section number at the top. Or at least the page number, if nothing else, right? There's a few people that I have no idea what homework this is. What do I do with this? So anyway, all right. Cool. So no other questions from homework? Okay. Yes?
Yeah, so a problem like these, do we have to follow the same procedure that the book tells us, where we always want to get the A by itself, like have the X squared by itself, and then, or can we just find, like what you're doing right now?
So the book, of course, it shows us the completing the square, putting it in standard form process, but it also shows us the shortcut method. So when can you use the shortcut method? When they don't say you have to do it any other way, right? So this question just says, find the maximum height. So what's the best way to do that? Negative e over 2a. Cool. If it says put it in standard form and then find the oh shit. Then we have to, this one would be remarkably disgusting if I said put this in standard form. Because you have to get this ugly number and then factor it out of 1 and then go forward. And actually, to tell you honestly, it actually would work out pretty nice. But it just looks like it would be gross. Okay, so in general, if I don't say on a test or something, if I don't say to use a specific method, then you can do either method you like. Right? Just the only time you're allowed to have the calculator tell you the answer is when I actually say, use the calculator to get this answer. Right? That's never an option otherwise. I like it. Don't tell me which buttons you press. I always love that. I showed you my work. I told you I pressed this button and then I pressed... Oh man, are you alright? Did that hurt? Yes. Yeah.
Number 82 on
3.2. Oh yeah, I love it. You throw some rabbits on an island. Is that the one about the rabbits? Yeah. Throw some rabbits on an island, give them some food, and then come back later and see how many rabbits there are, right? So, rabbit population on a small island is observed to be given by this function. And they give you the function. They give you what the graph looks like. So in 82, they tell you the population after some time is this. Okay. Cool. How many rabbits were there to start with?
1,000.
Yeah, beautiful. When you make times 0, you get 1,000 rabbits, right? Now, it makes sense that part of this is positive. The rabbits are going to be doing their thing. But what is this term all about, you think? The deaths in some way or another. Natural death, most likely not natural, most likely if there's any predators, foxes, wolves, humans. Huh? Coyotes, whatever. Disease. This is like the death factor, and this is the birth factor in a way, right? It's kind of part of what those are. You guys semi with me? And that's why it's going to attain. So they give you the picture of what it looks like, and they even have a little rabbit sitting on it, which is really fine. So somewhere in here, there's going to be a maximum population, right? They're going to hit some maximum population if it continues along this path. So whenever you hear about, we don't hear about this as much because a lot of the models are contradicting you earlier. We're still going to have a lot of people on the earth, but not as many as we thought. Because back in the 90s, for example, or even the 80s, there was all this, by the year 2015, everybody's going to have to stand on everybody else's shoulders, and it's going to be horrible. I'm going to walk around people's heads and say, when can I get up there? Shit. And that's because their models, were like, holy shit. And now we know it's not, holy shit, it's not as bad. Are you guys kind of with me? So we have these models that look at what's going on, and then they make predictions, and if those predictions don't come true, then the formula has to change. So if this holds true, then the rabbit population on the island will die out, right? And then the zombie rabbits come back. I'm still watching too much of the show. What are they asking here for? When is the maximum population attained? And what is that maximum population? Now, can you do this by hand? Is this quadratic?
Yes.
No. Why is it not quadratic? Yeah, it's 4. And no, it's not. So that's why they have a little picture of a calculator sitting there. Whenever they have this picture of a calculator with a little graph on it, that means you use your graphing calculator to get the answer, right? They give you the maximum function in the calculator. We've done that before, right? Second calc, maximum, left bound, right bound, that kind of stuff. You guys kind of with me? Okay, good. More of you guys are responding. This is good. Some of you are scaring me. And when does a rabbit population disappear from the island? You just have to find that intersection. Exactly. Well, and they might disappear because they're going off in the little tiny handmade rafts. Right? The coyotes are like, shit, screw the coyotes, get the hell out of here. Alright. Make a whole little story about these rabbits on this island. Alright. Let's get back into stuff. Last time we got 3:2. What I want to do is I want to do some new stuff, and then we'll go back and I'll show you how the new stuff fits into the old stuff. Right? Because the first step on the problems we did the other day was to do what? Sort of one of the very first key steps. Like, to give you a function, I'm going to have to factor it. Right? I know there's some things you can see from it, but one of the first things I want to do so I can answer other questions is factor it in multiplicity, get the intercepts, all that kind of stuff, right? I got to factor it. And I can't factor everything in the world with what you know, right? You don't know enough to factor anything beyond like a 4-term cubic thing, in a way, really. So we need to get some more factoring tools. So, first thing is, I want to remind you guys to make sure everybody remembers how to do long division of polynomial expressions. And then I'm going to show you a beautiful shortcut that only works in very specific situations, but when those situations arise, it kicks so much ass. And thankfully, those situations arise very often. Okay. So it only works in very specific situations, but that's exactly the kind of situation that we needed to work in. So it's like, oh, good. All right, thank you. So who remembers how to do this? So, for example, if I had do that. Normal 3. Of course, what would you try to do first here if I just said simplify this? Try to factor the top. Is the top factorable? No. Too bad for you. So if I said, what I actually would say on this problem is divide this, right, to be more specific. So let's remember how to long divide. For some of us, it might have been a while since we've done that by hand, right? And some of you guys might long divide in ways different from what we're used to. So recall, how do you long divide? Yeah, and I want to really point something out very specific that you do that you might not even realize. So you would say 71 into 508, right? What do you really do to get an idea for what number to put up there? You don't look at 71 into 508. You look at 7 into 50. I don't know if you even realize that's what you do. I mean, you look at 7 goes into 50 how many times?
7 times.
And then you put a 7 there and you see if it works. You guys... You with me? That's going to somehow tie into this, believe it or not, what we just did. Okay, let's keep going. So then you do
7 times 71. 497.
497. 11. Other than that, can catch up on some. Nice and peaceful and quiet. And bring down to 3, I like it. So you multiply, and then we look at that. Who said that? You're awesome. Yeah, change the sign. Then we combine them, bring this down, and then we do 7 into 11 goes once. So the 1 times 71 is 71 minus equals. Change the sign here, right? 42. And so we'd say, and 42 over 71. That's kind of neat. I like that. I didn't mean to make it almost perfectly square. Now, does everybody remember that? It's been a while since we've done that, right? Because you got calculators and you're like, why do we have to know any of this shit? It's too bad. So to do this, I do the exact same way. To be honest, you should have seen this before, but I get the feeling that might not be true. Gotcha. For some of us, it's been a while. Some of you, you've blocked it out. Your brain has developed coping mechanisms. So now, what did we do here first? Did we do 71? And no, we did 7 into 50, right? So what I do is I go x into 4x squared. It goes how many times? What times x is 4x squared? 4x. And then you do 4x times this. It's exactly. Why does it have to be exactly what we did over there? Because these are numbers. They have to act just like any other numbers do. So 4x times x, 4x squared, amazingly enough. 4x times negative 3.
It's negative 12.
Negative 12x. And then I change the signs. All right, it's related to subtraction. And then what do you get? So of course these cancel. They always have to cancel. If they don't, you did something wrong.
5x.
5x. Bring the plus 2 down. X goes into 5x 5 times. Switch the signs. So this will be plus 17 over x minus 3. Because I don't know if you realize, I mean, there's an understood plus sign there. Do you guys know that? And actually, that's the evil thing that screws so many people up when they first learn this. Is that fact that we decided to write it like it looks like multiplication, but we go, there's a hidden plus sign in there. Aha. So here we have to actually show there's a plus sign there. Now, real quick, I want to show you something. That remainder means something interesting. This obviously didn't go in evenly, and that relates to the fact that this is not factorable. What does this remainder here mean? In order for 71 to go in evenly, this number is how much too big? 42. It's 42 too big. So if I took 42 away from it, 71 would have gone in evenly. Does that make sense? We know this. 8 goes into 9 once with 1 left over. That stupid 1 left over is because that's 1 too big. to go in evenly, right? So this is how much too big? 17 too big. So if I had 4x squared minus 7x minus 15, you guys see that? Take 17 away. Now x minus 3 will actually go into it. That's factorable. That factors as x minus 3 times something, which we can actually figure out. 4x. What's that got to be? Plus 5. Let's see. Minus 12 plus 5 is minus 7. I like that. That's a little side note. There's nothing that you have to actually be consciously aware of to do this work, but I like to show that's what the remainder really means. It's how far off it is from going in evenly. It's kind of nice. And going in evenly would so kick ass here, because then I would have been able to factor that thing. So when we start to do this, if I try to factor something using the method I'm about to show you, we desperately want the remainder to be 0, because that means we found a factor of the damn thing, right? And that's the whole point. We want to find all the factors of it. Okay, maybe I've got you with me. You're all looking in this direction. Okay. That's at least one good sign. All right. So let me show you immediately. This will work for any division where, the top is a higher degree or the same degree as the bottom. Kind of with me? So it's a top heavy or they're even degrees. If the top was a lower degree than the bottom, then it's already sort of fractional. Does that make sense? So I wouldn't waste any time doing 8 goes into 7. That's kind of a stupid question. How many times does 8 go into 7? None. With 7/8, okay, so what was the point? None. So if it starts off as x squared plus blah, blah, blah over x cubed, blah, 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 I'm not going to long divide. It's already fractional. The bottom is bigger than the top. Does that make sense? Mm-hmm. Okay, another little side note, but still good to know. Now, let me show you the shortcut to this. The shortcut only works, and the shortcut is called synthetic division. Which I just love that name because I immediately think about synthetic tennis, synthetic gut tennis wires, tennis string, right? That's not really related. So here's the beautiful thing. Now, and I love the look on all your faces when we started doing this. You're all like, that exists? What the hell? And this can get remarkably, disgustingly long very quickly, right? But what were the only really important parts? This part of the work is so desperately not important because it cancels. Who gives a shit? The most important parts of this problem were these parts. Right? Because then that gave me the 5, which actually was what goes up here. And this part. Who cares about this? That tells me what goes up here. You guys... So what the synthetic division method does, it does a couple things. One, the most common mistake people make in this problem is they forget to change the signs. So synthetic division says, let's change the freaking sign at the beginning so that I don't have to do it every time. Right? That sounds nice. I appreciate that. I can get into that. All right? And so here's what synthetic division would look like for this. So, and how important are the variables themselves? How important are these variable things? As long as they're in order, I don't care. What's most important are the numbers, of course, right? The numbers are what's important. So the synthetic division, it strips away all the variables. You have to make sure everything's in the right order. If I was missing like an x term, you better put a 0 there, that kind of thing. Are you with me? So this synthetic division, it only works when dividing by x plus c, just to put a constant there. So not only does the bottom have to be linear, it actually has to have a 1 in front of the x. So if you want to divide by 2x plus 1, you could still do what we're about to do, you just have to factor the 2 out, and you divide by x plus a half. Which sounds horrible, but it's not horrible. You got to trust me on that. Right? You're like, we don't trust you, man. You're a math teacher. I don't blame you that much. All right. I looked like I was going to make a list, but that's my list. So here's what it does. I don't watch much hockey, but I call this the penalty box. Right? And we're going to strip away all the variables. They don't matter. I've got everything in the right order here. So I'm going to not put the x. So you think I'm going to put a -3 in there, but what did I say? I'm going to change the sign first. So I'm going to make this a +3. So a way to remember that is, what's the 0 of this? You put that in there. You guys semi with me? Alright, so here we go. And I like doing this side by side so I can show you the parts that relate. Now up here you just put the coefficients. You strip away the x's. So up here I'm going to put what?
4, -7, and 2.
I like it. Now, why was this 4 here? Why was that 4 there? Because of that 4, right? I love it. If this is a 1, like this needs, the answer is always going to have whatever that number is. So, the answer is going to show up below this line. Below this line is going to be the answer. So that's why the first step is always bring the 4 down, because that's always going to be a freaking part of the answer. Right? Does that make sense? That's what gets us started. I like it. Now, to kind of mimic this, what I do now, what did I do with that 4? I multiplied by the x, or the 4x times x, and I got this, and this is the part I don't care about. What was important was 4 times 3 was 12, right? So then you bring this down, multiply. 3 times 4 is 12, add. And that's exactly this step here, right? This step right there, you see that? I really want you with me. Some of you have looked away. I'm worried. Okay. -7 plus 12 is 5. -7 plus 12 is 5. Then how do I get that? Multiply. Add. That's the remainder term. Right? So since we stripped away the variables, you have to be careful when you bring them back in. They started off as an x squared. I divided by something like x. So my answer has to start with what power? X to the first. So if this was cubed, this would have been the coefficient of the x squared term. It's going to go down by a degree because I'm dividing by a degree. Does that make sense? So start off as squared, so I know this is 4x plus 5 plus 17 over x minus 3. When I pointed it at, I didn't mean 3. This represents x minus 3. How you guys feeling? Alright, so I'm going to put a problem up here. I want you to do it both ways. So I want you to do long division, and then I want you to do synthetic division. Alright? Everybody's got this here? Alright, let me put it over here. So I'll do this problem. Do it synthetic, do it long division, and synthetic division. What you got, John? I don't know. I make no claim as to what the numbers are going to come out to be. It's a good way to absolve myself of all my sins. We'll see what happens. By the way, can anybody predict if this is going to go in evenly or not? You're like, what the hell? If it was going to go in evenly, that means that x plus 2 would be a factor of this. Which means the last number would have to have 2 as a factor, wouldn't it?
Yeah.
Does it?
No.
So I already know it's going to have some kind of remainder. I like it. But I still want you to do it. I don't care. Do it both ways. Yeah. Because you know, when you do long division, this number comes from 3 times 2, right? And then you have to change the signs there, though. So the subtract that. Yeah. Exactly. Okay, 13. But that, if I make that 2 a negative to begin with, then I don't have to change the sign every time. It's built in.
That's what I was thinking.
Sure. Exactly. That would mean that that would be a factor of this, if that was a 0. Which later becomes like really important. You want that to happen. Yeah. Yep. Cool. So, I don't know. If you think these are big numbers, I don't know. They're not. Okay, so what's the first step here? Yeah, 3x squared times x is 3x cubed times 2 is plus 6x squared, but then I have to change the signs. So then I get, bring down to 2x. Thank you. So then negative 13x squared.
26.
Yeah, minus 26x, and then you change the signs. So you get 28x, bring down the 11. Yep, so plus 28, 28x. 56. Change the signs. So you get negative 45, so minus 45 over x plus 2. Cool, I like it. And I added one extra term, and this is already getting kind of like, oh God. Right? Looks like a, I don't know why I suddenly thought of this, an upside down wedding cake. I haven't had any friends get married. I don't know if you know what I'm talking about. Up at the top. Alright. This one, how does this work? So you gather together, you've got the 0 that goes with this, is how you put that number there. But remember, the reason it's negative 2 is because I'm changing the sign. So where did that negative 6 come from? It came from 3 times 2, and then I had to change the sign. So that method says, just make the 2 negative to begin with. So that I don't have to change the damn sign every time. Right? Now I sound like Bill Clinton. So now, how does this work? Drop 3, negative 6. Add, multiply, add, multiply, add. And of course, those are the coefficients of the answer that we already got, right? You guys kind of... Now, just real quick, just in case you're wondering why we ever do this, it's because what if I was dividing by x squared plus 2? Synthetic only works for linear. In fact, it's very specific linear. The first term has to be, the first coefficient has to be 1. From the bottom of x squared plus 2, I can't use synthetic. I could, but you'd have to use plus or minus radical 2i. You want to do that?
No.
All right. So that's why we still sometimes use long division, is because synthetic really truly only works well with things that look like that. Long division is for basically everything else. Right? And what's really nice is this gets gross, but this is basically always the same width. It can just get a little bit longer if I add more and more terms. It's nice. It's a very manageable amount of work. Yes, sir?
So you can put any amount of terms on top as long as the bottom.
As long as...
The bottom is or
Yeah, to use synthetic, exactly. Yeah, good. All right. I like it. Okay. That's not too bad. So now what's going to happen is, just to give you an idea, we're going to kind of get into this a little bit. Let me give you one of these to show you. So we got all this here? Okay. Kind of playing off of what we just did earlier. If I said, let me just give this to you and see your reaction. If I said, factor this polynomial. Oh, well, I can.
You see a factor?
Yes. What method that we had before today would you have to try? Grouping. Would grouping get you anywhere? No. Scheisse. So then what you do is, now I'm not saying divide this by something, but that's effectively what factoring means, right? Why do you factor 18? And why is 1 away 2 times 9? Because 18 divided by 2 is 9. So if I can figure out what divides into this, I can then figure out how to write it factored form. You guys semi with me? All right. So the first thing we need to do then, what's kind of missing then? Since I don't have a bottom, what's missing to get me started with synthetic?
X.
Yeah, there's no x minus 7 or something on the bottom. There's nothing to get me started, really. You guys with me? And I know I'm going to use synthetic because I know this is going to factor like x, blah, 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 maybe 3 of these things, right? Or maybe 1 with a quadratic that I'd have to like use a quadratic formula on if I'm setting it equal to 0. All you guys semi with me? Okay, cool. I like it. Of course, eventually we're going to have to talk about what if I put a 4 out there or something. That always screws everything up, right? It's going to screw up a little bit. So the very first thing I need to do is make a list of numbers that make sense to put in my penalty box. Does that make sense? Remember earlier I said, how did we know it wasn't going to go in evenly? Because 2 doesn't go into 11. So tell me, what's the list of, let me make this very specific, possible rational root. Good Lord. That's the official name of this list we're about to make. This is a list of all possible rational roots.
-7.
What?
-7.
What's got to be true about the numbers that go here, here, and here? They got to multiply by 8. -8, right?
2, 4, 8. 1, 2, 4, 8.
All right, good. 1, 2, 4, 8. Factors of 8. Plus or minus, right? Some positive, some negative, so I end up with a negative. You guys with me? Does that idea make sense? By itself? Okay, I love it. I mean, that kind of makes sense. If I don't have anything to go off of, I want to give myself a list of things to try. And I'm not going to try 11, because 11 doesn't go into 8. Yeah?
Since we know that the degree of the leading term is a cube, can we assume then that that's going to have some influence on this? Because I still think that thinking x minus 2 is going to be the magic number here.
Maybe. We'll try that. We'll try that first. This degree will have nothing really to do with the choices I make, to be honest. We are going to, now trust me, can you imagine this list getting big easily? So what you actually have to do is try everything on the list until you get something that works. So thankfully, this is just the beginning of this discussion. We're going to develop ways to shorten that list before even trying it. There are certain things we can do to shorten that list. Thank God. Right? So, I don't know if you guys are really with me. Does everybody understand the idea of where that list came from? That 8 came from these 3 numbers multiplied? So it's got to be, if there's going to be rational roots, it's got to be one of these numbers here. Now, let me throw this out there. I could factor out a piece like this, and then the rest would be some ugly, not factorable thing. Is that possible? Yes, but I could still factor this if I find the roots of this. And how do I find the roots of this? Quadratic formula. So this is only going to help me figure out what are the possible rational roots. There might be some irrational or even some complex roots that I have to get a different way at the end with whatever's left over. It's like trying to break something down, trying to get a stump out of your front yard. You can't break this part out. And you're like, shit, this clump. I got to do something with this clump. So that's the clump at the end. You're like, I got to do something with that clump. I've actually never done that. I don't know where that came from. All right. So let's see. Blah, 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 blah. So what are we going to try first? Let's go ahead and try 2. And what would that be related to? What factor would that be related to? All right, so we're going to see if that is a factor of that. And the beauty of synthetic is, even though I have a lot of numbers to try out, synthetic is pretty quick, and you don't even have to go all the way to the end. You can tell pretty early that it's not going to work. Does that make sense? Be a little careful about assuming too much, but you should be able to see if it's going to work or not. So what do I put up here?
1.
All right, let's see. That's the magic number. Good pick. Sweet. So this is why, if the list is going to be really long, I give you kind of a hint to start you off, because otherwise you're either lucky or you ain't. And it's like the last number you try is the one that works, and then the test is over. Give me your test. Oh, shit. Yeah.
Doesn't that work if it's a perfect cube of 2?
That doesn't matter. To be honest, it could have been 8, 1, and 1. Right? But 2 is the good bet. But now what's left over? Now here's what's interesting now. I can kind of update my list now. What am I working with now? What have I factored this as so far?
X squared.
Alright?
X minus X.
You guys with me? That was how we factored it so far. Make it look more like a 4. There it is. And of course, now at this point, I wouldn't even use synthetic on that, right? The minute you get a quadratic left over, either it's factorable or you have to use quadratic formula. Is that factorable?
Yes.
I like whoever said no. Even if you do it, still not. But this is going to work, of course, because that's positive, so I need 2 negatives that multiply by 4, that would have to be -4 and -1, and they make -5. There it is. Cool. And of course, look, 1, 2, 4, 1, 2, 4, they were all parts of our, of course they were. Right? It could have been 2, 2, and 2. Now be really careful. Just because 2 worked doesn't mean you cross it off your list, because it could show up multiple times. You could have multiplicity 3, right? So be real careful. That's another big mistake I see is people say, oh, it worked, let me cross it off the list. No, shit, it could go in multiple times. All right, good. Maybe. The only way you can cross it off is if it's not 0 here, right? Then you know it doesn't work. All right, how are we feeling so far? Let me give you another one of these to try on your own. Let's see. Feel free to collaborate with others near you. Somebody might get lucky and get the actual number that works. case there's somebody who can't exist without knowing this, we've actually sort of gotten into section 3.4 just now. Just to let you know. 3.3 is only about synthetic and long division. 3.4 is what we're doing now. Sneak. Okay, guys. Well, we'll see what happens. But you see on it has to multi positive 12 at the end? And negative 3 to negative 4. It's weird. So somewhere there's something I can't see. Let's see. Who got one that works? What'd you get? 2. All right, 2 is the magic number. So then what did I put up here?
1, negative 8, 12.
So let's see. 1,
2,
2, 1,
2,
2, negative 6,
negative
negative 12, 0. Sweet. So then, so far we got this to factor as x minus 2 times,
X squared.
so this would be x minus 2
x minus 2, x
plus 3, yeah. Oh,
that's
I can't believe I didn't notice. Because that relates to x plus 3. I knew it was somewhere. And a really good check to make sure it at least looks like it has a chance to be right. 3 times negative 2 times negative 2 is 12. Right? Just quick check at the end to make sure nothing went freaky in the middle. You guys semi with me? So everything we did yesterday could actually have this as a first step. Because then what did I do here now? I can get the x-intercepts. The multiplicity of 2 would be what? 2. 2 is just a number, man. You guys kind of follow? So this was given to us yesterday. And now I could give you this and say, factor it. And, so this whole thing would be the first step. And then you keep going to graph it. Multiplicity, and then you draw the number line and see how it's moving around. You guys semi with me here? Because now we have, I don't know if you understand, but if you've never seen this synthetic division, or if you've never seen it used to factor, your ability to factor has just gone crazy, right? You have leveled way the hell up today. So you can handle a lot of shit. If it's factorable, you can basically do it. You could do it. Yeah, you can feel it. You can feel it, right? It's like a power just coursing through you. You can't fly. Don't jump off a building. Mr. Wallace said I have power. All right. I want to talk about a couple things about how to decrease the list. But before I do that, before I forget, I need to go back and talk about what do you do in 2 situations. Well, let me make this first number, make it a 9 just to make this more interesting. Obviously, since you just made this up, I'll bet you any amount of money that this won't factor nicely at all. You with me? So it's not my point here. I want to talk about what to do if that first number is not a 1. And we know what to do, to be honest. If that first number is not a 1, it might factor to be something, not in this case, but it might factor to be something like this, right? What are the zeros of this? Yeah, -1/2 and 4/5. Now, if you multiply this out, you get 10x squared plus 5x minus 8x, so minus 3x minus 4. You with me? All right. And notice, these two are just the actual answers. The list of possible answers is going to be much larger, but let's see if we can tease out where this came from. 1/2. Whoa. And 4/5. So these came from, and what's 5 and 2? It's related to the factors of 10. And 1 and 4 are related to the factors of 4. So to make the total list of possibilities, you take the factors of this, divide it in every combination you can with the factors of this. So what would the list of possible rational roots, the list of per, what would that be for this?
1/9.
Yeah, well, the way I would start off is to write all the factors of 8, plus or minus. So what do you get? We just did that one. So 1, 2, 4, 8. And all the factors of 9, which are what? 1 through 9. And now you make every possible ratio that you can. And that's the total list that you would have to check. If I didn't ever give you the ways to reduce your list.
So we got the factors for either and equations?
Yeah, so the list of possible rational roots for this whole thing is going to be the roots of the last number divided by the roots of the first number. Because why was there a 5 on the bottom of that answer? Because that was a 5 in front. Right? So it's the list of total possible answers are all the factors of this divided by all the factors of that in every combination possible. So for example, I always get 1, 2, 4, 8 again, because that's divided by 1. And then I also get, this is plus or minus, right? I also get what?
1/3.
1/3, 2/3, 4/3, 8/3. 4 I already got, 4/3 I already got, 4/9, that's new. What am I doing? I'm going to do this in the same order, sorry. Am I? Yeah, 2.
2 ninths.
Oh, I did 2. So 1/9, 2/9, 4/9, and 8/9. So now it starts to feel like a lottery, right? Your odds of winning. So thankfully, the next thing we'll talk about a little bit is a couple ways to reduce the size of your list that don't always work. Sorry. So on a test, I'm obviously going to guide you a little bit. I'm going to help you truncate your list as much as I can. You actually have to understand what it is I'm trying to say. You have to understand the idea behind what we're about to do. But you're never going to have this long of a list to check. I mean, that's just busy work. That's just insane. I'm not going to make you do that. So if that's what's happening, you need to come up to me and say, am I missing something here? Can you help me? Can you help me out? It's a cup with dirt in it. Sorry, I just heard that routine the other day. Again. All right, so the first thing we got is this guy. Anybody remember this guy? This poor guy? Descartes.
And therefore, I think.
Yes, I drink, therefore I am. I mean, I think that, therefore I am.
Yeah, that's the Irish version.
True, exactly. And then they say, do you want to go over here? I think not. And then he disappears. But, because then he isn't. But Descartes, the guy that came up with the Cartesian coordinate system, Cartesian, right, that kind of thing. He was supposedly, the story is he was laying on his bed, he saw a fly walking around on the wall, on the ceiling, like, that's an awesome life. But let's say he was sick. And he's realizing I can model how that fly moves with like grids, and then he came up with the idea of the Cartesian coordinate system. That's a pretty decent thing to do, right? So he also came up with this rule, and we have to give him a little bit of, sometimes, very infrequently, this rule kicks so much ass. Most often, this rule doesn't do shit for us. But it's just good to know. And in fact, I'm going to develop the test so that the rule actually does something for us. Are you kind of with me? I can make a problem so that it actually does something for us. So here's the interesting thing. Let me see if you guys... let me just put it up here so what you guys think. So if I have a polynomial, and all the terms are positive. And the whole idea of factoring is intimately related to figuring out what makes it zero. Are you guys with me so far? I mean, if I'm figuring out what makes it zero, that's related to one of the factors. It's got to be, right? They kind of go hand in hand. So what are the only kind of numbers I could plug in for x in the situation that would actually make that happen?
Proposition.
Think backwards. Because if I plug in a positive number, it's got no chance. If I plug in 0, it's 9. So if I plug in anything else, it's more than 9. So is it going to ever equal 0 for any positive number? No. So what are the only possibilities then? Negative numbers. So if you had this polynomial and you had like a list like this, you can automatically chop it in half, right? Do you realize, and you guys didn't realize this maybe, but this list is twice as long as it looks because you got positive and negative. But I can cut that list in half because now I can ignore the positive possibilities. Are you guys with me?
Yes.
Thank you. Now that's actually pretty lame because how often does that happen? Not very. But thankfully it's a little bit more robust than that. What we really do is we count the number of sign variations. And stay with me now. So I did an extreme situation. How many sign changes are there as you step through? As you step through from term to term, how many sign changes are there? None. So the sign changes that I see in the polynomial itself relates to the number of positive rational roots that are possible. Let me say that again. Good Lord. The number of sign changes I see relates to the number of possible positive rational roots. Since there were no sign changes here, there can be no positive possible rational roots. Are you with me? All right, cool. All right. If I want to know the negative, so there's no sign changes, so there's no positive rational roots. What about negative roots? How do I check for the negative roots? What I do is I look at what would the function look like if I plugged a negative x in. So what would it look like if I plug a negative x in? Does somebody see a shortcut for this? What terms will actually change sign? The odd degree terms. Because what's negative x squared? X squared. So see, these guys are going to stay this. Of course, 9 doesn't give a shit what x is. So, x changed. I didn't know. So, but this guy, obviously, negative x cubed is going to be negative. This guy stays the same sign. This guy, of course, directly changes. You guys with me? Plug in a negative x in to see what it looks like. And that's plus 9. So how many sign changes do I see now?
2.
1,
One positive.
2, 3. So as I step through the polynomial, how many sign changes are there? Be careful. Don't just look at the signs or something. Actually go from term to term. So there's 3. So there could be 3 possible negative rational roots. You guys with me so far? Now here's where things get really interesting. This is really interesting, and I think this is where I'm going to leave it. Let's stay with me. If there were any complex or irrational roots, how many of them would there have to be in general? Could you have one complex answer? No. If you don't understand why not, where do they come from? Where do irrational or complex answers come from? The who, the what formula? Quadratic formula, right? What's in the quadratic formula in the middle of it? Plus or minus. So that radical, if it's there, it could be a complex number or an irrational number, and then therefore there are 2 of them. So they always show up in these conjugate pairs. Holy shit. So if one answer is rad 7, 2 plus rad 7, another answer has to be 2 minus rad 7. You guys kind of, it's because of the quadratic formula. It's got the plus or minus in it. It's very interesting. So either there's 3 negative rational roots, or there's 1 negative rational root. So you always go down by 2. Why would I go down by 2? Because if it's not rational, it's irrational or complex.
There's 2 of them.
Yeah, I like it. And there's always got to be 2 of them. So if I saw 8 sign changes, then there could be 8 or 6, or 4, or 2, or 0, right? So now you see the kind of the lameness built in. It's still a decent rule. It still works sometimes, but most of the time it's like, well, it could be this or this or this or this. Thanks, Descartes. Thanks a lot. Look at your flies. All right, maybe. So obviously I could build a polynomial where one of these two is going to be 0 possible, and then your list automatically is cut in half, right? So you're not just sitting there doing busy work all day, because that sucks. I hate that myself. All right, that's plenty. So let me say this. Of course, I say this on the way out. I have a quiz. I actually have a quiz on next Monday and next Tuesday, just to be evil, to be honest. So quiz on Monday. Monday and Tuesday. Quiz on Monday is 3-1 and 3-2. And the quiz on Tuesday will be 3-3 and 3-4.